Welcome. Welcome back. Welcome to Vaayusastra's Future Scientist Meet chapter number 19. As usual, we have 5 researchers who is going to decide the future of space industry. He's sitting, he's along with us to do unique and new presentations. And that's our target space team holds the maximum number today. We have Darsh, Vignesh, and Bhairavi. Other than that, we have Riya and Himesh. And okay, let me introduce what is Vaayusastra for the viewers who are watching it for first time. Vaayusastra is an edutech startup and research and development startup incubated under IIT Madras. So we started this initiative during this pandemic period. It's called Trigger the Spark. After researching life of people like Elon Musk, Wright brothers, Abdul Kalam, we designed a curriculum where there's a lot of story, a lot of science with some hands-on activities, which goes for 9 levels. Once the student reaches all these 9 levels, they will be upgraded to young researchers group. Like this, we have more than 100 students till now. And all these students do presentations every week. They have their own team, own companies. Even some teams registered at their own company. So basically, I look at all these people as the future of space industry. People who have this heavy potential to decide things to take humanity to next level. Okay, today we have our first presenter. She is Riya. So Riya is from Isha Vidya Matriculation Higher Secondary School. She is a grade 9. And her topic is flying sphere of atmosphere. Okay, it's like flying sphere of atmosphere. Riya, I'm going to pin you here. Okay, tell us more about your topic and the stage is all yours.
Okay, Jagu, let me share my screen. Is my screen visible?
Yes, it is visible.
Okay. So, namaskaram everyone. I am S.J. Riya from Isha Vidya School, Nagarkoil, studying grade 9. And today's topic is the flying sphere of atmosphere. So, topics we are going to cover: introduction, what you will learn from my presentation, introduction to spheres, the plane spheres, bird and plane, the technical spheres, why some birds fly high, why some birds cannot fly high, and difference between concorde and normal plane. Questions time, quiz time, and finally conclusion. So let us begin. Introduction. Everything needs an atmosphere. Depends upon the atmosphere, everything exists. Everything develops and everything goes beyond it. Likewise, the earth also have different spheres in its atmosphere, where things exist depend upon the atmosphere. You all know that our atmosphere have 5 spheres, namely troposphere, stratosphere, mesosphere, thermosphere, and exosphere. But only in a few spheres we can use for flying planes, and birds also will fly in that sphere. So we are going to learn why planes and birds can fly in a few spheres, why they can't fly in other spheres, and why some birds fly higher than other birds. Why other birds can't fly. So now introduction to the spheres. While observing this image, you can understood. In troposphere, we can fly planes. They have clouds. Birds would fly here. We have hot air balloon. So the distance of the troposphere from the Earth is 0 to 12 kilometers. And next is ozone layer. It's between stratosphere and troposphere. But Ozone layer, it is 20 to 30 kilometer. The next one is stratosphere. Only Concorde plane would fly here. So the stratosphere is between 12 to 50 kilometer. And the next one is mesosphere. The aurora borealis and the meteoroids form here. The mesosphere extends from 50 to 80 kilometer. And the next one is Kármán line. It is at 100 kilometer. Then thermosphere, satellites would fly at this thermosphere, and it's from 80 to 700 kilometer. The next one is exobase. It is from 700 to 1000 kilometer. And exosphere. Rockets would commonly fly here. The exosphere is 700 to 1,90,000 kilometer. So let's move on. The plane spheres. Troposphere and stratosphere are the plane spheres. Because normal planes and supersonic planes like Concorde plane fly here, they won't cross the stratosphere. Commercial aircraft typically fly between 31,000 and 38,000 feet. It is 9.4488 kilometer to 11.5824 kilometer, which is actually in troposphere. And Concorde plane flies 6,000 feet, which is 18.288 kilometer, which is in stratosphere. Concorde plane was retired from service in October 2003. Birds and planes. Birds won't cross troposphere and it can nearly fly to stratosphere. The highest flying bird is the Rupel's griffon vulture, which can actually fly 37,000 feet, which is 11.2776 kilometer. The maximum height of the plane is also nearly 38,000 feet. So both fly at the same height. Only 1 feet is the difference. Bird and plane. Have you ever wondered why planes and birds can't cross the stratosphere? As birds, they go higher, they have to flap harder to stay aloft. So their metabolic demands increase. The oxygen levels become more limited at high altitudes. It gets colder and they need to keep their bodies warm. And the air gets drier. They are more likely to lose water from breathing and evaporation and be thirsty for all time. The air is extremely thin in the stratosphere. Oxygen level will be also low. This will cause air turbulence and uneasiness to the passengers in the plane. As we need oxygen, the engines in the plane also needs oxygen to work. As we go higher and higher, oxygen and density of the air decreases. So the aircraft engine can't work and a plane can't glide in air. So one thing, if you are wearing earphone or a headphone, please remove it because there is one video. It is the real sound of a plane. So if you wear earphone means it will affect your ear. It is that much loud. So
kindly remove your headphones. Ta-da.
Is everyone removed? Okay, let me play.
Yes, yeah, remove.
If this sound itself affect your ear, then think of in supersonic plane, if a sonic boom happen, what will happen to the ears? So now continue in the topic. Why some birds can fly high? Some birds fly higher than others because their prey or food sources are located at higher altitudes. Higher flying birds also have the physiological ability to do so with enhanced adaptations for oxygen intake, circulation, and absorption within their bodies. Rupel's griffon vulture, bar-headed geese are such examples of birds. This is the Rupel's griffon vulture.
Nice.
This is the Rupel's griffon vulture. It could nearly fly like a plane. So next, difference between Concorde and normal plane. In Concorde plane, the Mach is 2.04, more than twice the speed of sound. So it causes sonic boom. A typical commercial passenger jet flies at a speed of about Mach 0.75 to 0.85. Concorde plane flies at 60,000 feet. A typical commercial passenger jet flies at 31,000 and 38,000 feet. See, this Concorde plane is double than the normal plane. A Concorde flew faster and higher than the most commercial jets. For example, a Boeing 747 aircraft cruises at about 560 mph, 901 kph or Mach 0.84 at an altitude of 35,000 feet, which is 10,675 meters. In contrast, the Concorde would cruise at 1,350 miles per hour, which is 2,172 km per hour or Mach 2 at an altitude of 60,000 feet, which is 18,300 meters. Because the Concorde traveled faster than the speed of sound and almost twice as high as other commercial jets. It had several features that set it apart from other aircraft. Streamlined design, needle-like fuselage, swept back delta wing, movable nose, vertical tail design, engine design. Engines built into the wing afterburners. So the technical spheres. The remaining three spheres are the technical spheres: mesosphere, thermosphere, and exosphere. Why we call it technical spheres? Because we already have the technology of flying up to stratosphere. So we develop from that and use new technology to fly in those spheres. A line from why some birds can fly high. This is the line. High flying birds also have the physiological ability to do so with the enhanced adaptations for oxygen intake, circulation, and absorption within their bodies. The same happens in a rocket or plane, which flies higher. It will be made with the same physiological adaptation and enhanced adaptations. So the engine works and we can breathe by using space suits. Any questions?
Question time.
No questions.
I think this topic is quite familiar, and we can also ask more doubts as well.
It also went somewhat depth.
Yes. The birds information, the birds video shown are amazing. And even the
Some
sound.
of the people just know the overview of it. This thing.
It's amazing presentation.
Nice. Also put your feedbacks in the YouTube live as well. Because
Nice
this is one of the
presentation.
very beautiful presentation.
If you don't have questions, then my questions to you.
Okay. Quiz time.
No need to answer here. I have quiz. You can answer me in the feedback. I have the questions there also. Planes can't fly higher than 38,000 feet because of less amount of oxygen. So if we mix the fuel and oxygen, same as a rocket, and send a plane to sky, can it fly in space? Your opinion. So the next question is, why a plane is not flapping its wings like a bird? The next question is, how the plane see what is happening down while flying? Fourth one, while a bird is landing in the land fastly, no accident occurs. But when a plane lands quickly, why accidents are inevitable? These are some own questions you can answer on your own.
Riya, what is the third question? I'm not getting properly.
Yes, Jagu. How the plane can see what is happening down while flying in the sky?
Okay. How, what happens in the ground? How the pilot knows? Okay.
Yes, Jagu.
The camera.
Yeah. You can answer. You can. Whoever knows the answer for this question, raise your hands. I'll unmute you, or you can unmute yourself actually.
So now quiz time.
I think they can answers. I think few of them have answers.
No quizzes.
Quiz the ball. First to tell the answer. Planes. The first question is very interesting question. You actually know the answer. Who wants to answer it? Riya, go to the questions thing, no?
Yes, Jagu. Okay,
Planes can't fly higher than 38,000, like 10 kilometer, 12 kilometer range. If we mix oxygen fuel like rockets, can the plane can fly? That is the question. Who wants to give your views? It may not have to be right. So you just think and tell. You either put in chat box or Vignesh, you are muted. Okay, who wants to try? அதாவது 10 கிலோமீட்டர் 12 கிலோமீட்டருக்கு மேல ஆக்சிஜன் வந்து கம்மியா இருக்கும். பிளேன்ஸ் வந்து யூசுவலா they won't fly because of low oxygen, or ஒரு ராக்கெட் மாதிரி if we mix fuel and oxygen, can the plane fly like a rocket? ரீசெண்டா பார்த்திருக்கலாம் Virgin Galacticலாம். So you actually know the answer. Who wants to try? Madhyesh, you want to try?
Sir, I think we can send a plane the mixing fuel and I did not understand the second question.
Okay, so Madhyesh said yes, we can. Yeah, Madhyesh is actually saying yes, we can. If we cannot mix the fuel and oxygen, we can actually fly.
This is Anish. Yeah, it can do. If you mix oxygen and fuel, it could
Yeah, you can carry the oxidizer along with the fuel, and you can
Yeah.
actually make plane to fly.
like
Yeah,
we
possible.
design it in a way that it is it should be like made of iron to withstand heat, and should be in a way like the engine should be in sides, not in the center like usual planes. Like they have in the wings, but it should have in the
Nice.
end rear.
Okay, so Anish, whatever you're saying is right. We need to design in such a way it also should withstand the re-entry temperature, the speed, all those things.
So it should adapt in space and
Yeah, adapt to that environment. Okay. So the quiz link is up.
For me, there is not link.
Already 3 of them joined. It's 3.
Yeah. You can use the link. I'm putting it in YouTube live as well. We got some presentation, some comments in the YouTube live as well. Super wonderful, nice. Okay, quiz time. Nice, Riya. I think we can start. All are joined.
Wait,
All
sir, I
the-
will join just a second.
Yes.
Some of them are joining, Jagu.
I think the house is full except me. All are joined. See.
Then you also join Jagu.
Join பண்றேன். Because if I focus on that, I need to take care of these things around. The live is going
Sir,
on.
1 minute, sir. I will join now.
Okay. Put it in your school group as well. Isha group as well.
Yeah, Jaga, I put it.
Yeah. I think you can start.
Okay, Jagu. Have you joined?
Not yet. So I told you, I'm handling this live also here. So
1 minute, Akka. 1 minute.
Okay.
வேற இருந்தா விட்டுட்டு வருவேன். So technical glitches ஆயிடக்கூடாது.
It is loading, sir.
Okay.
Maybe you can join from
Jagu quiz create பண்ணனும் நம்ம அந்த quiz app download பண்ணனும்.
ஜாயின் பண்ணிடுவோமா?
Yes, Jagu.
Okay, நான் என் போன்ல இருந்து ஜாயின் பண்ண ட்ரை பண்றேன். So I am not touching my system. So
Jagu quiz create பண்ணனும்.
okay.
Jagu quiz create பண்ணனா quiz app download பண்ணனுமா?
Is it timed one, Jagu?
Timed one? I don't know da. I am also clueless.
Okay. 20 members I start.
Okay, start.
Ozone layer is between which two spheres? Option 1, exosphere and stratosphere. Then second option, thermosphere and exosphere. Third one, troposphere and stratosphere. Then fourth one, mesosphere and thermosphere.
Oh, timed. Okay.
Okay, next question. Which vulture flies the highest? First one, Russell's Griffon vulture. Second one, Ruppel's Griffon vulture. Third one, Ripple's Griffon vulture. And fourth one is Griffon vulture.
Jagu quiz create பண்ணனா quiz app download பண்ணனுமா?
அப்படிலாம் ஒண்ணும் இல்லடா. Directly I can click the link. I'm just randomly clicking something.
When Concorde plane was retired? First, October 2003. Second, December 2008. Third, September 2003. And fourth one is November 2008.
ஐயோ. It's October 2003. I selected September 2003.
Same Jagu, I also give that one.
Which sphere you want to live?
No one can answer.
No one can answer.
Yes. Which sphere you would like to live? It is like a fill-in. You can answer whatever you like.
Okay.
Response view. Stratosphere, Pranadeep, stratosphere. Sadhana, atmosphere. Anusara, troposphere. Manish Noel, exosphere. Sanjay, what Jagu?
இல்ல continue.
Sanjay, thermosphere.
I like this quiz.
Troposphere. Earth, Sunil, Earth. Vignesh Anirudh, atmosphere. Darshay, mesosphere. Adrit, troposphere. Matyesh, stratosphere. Nivas, atmosphere. Divisha, elithosphere.
Elithosphere?
Yes.
What? Why can't? Why it's coming wrong?
Yeah, why it's coming wrong?
You only said with sphere, and that Earth is not enough sphere.
Yes, everything is correct, but it is all on the Earth sphere, so Earth is the correct answer.
What?
Okay, fine.
Like you like to live. You
What?
should not choose wisely.
It's not even a sphere. Earth is not in a sphere.
Yeah, Earth is
It's
not
okay.
a sphere.
Our Earth is also a sphere, no?
No, it's a.
No, it is not. It is only troposphere.
You
Very
asked us what would you like to live on?
It's like
etc.
jolly.
And
Which
moreover,
is
you
the
said
correct
which
thing
sphere you
on
would
to
like.
live on?
Sorry, next question.
Okay,
Next
okay,
question.
give everyone the chance.
How much kilometer exosphere extend?
The next one is a bonus question.
All answer looks right only.
Yes, it's a bonus to know what you learned.
Mm. Okay.
Let us see the leaderboard. Next question. Yes.
It is thrilling ஆயிடுச்சு.
Who's first?
சாதனா, அனுஷாரா, மத்யேஷ். மத்யேஷ்.
Anushka, my friend from Isha School, Jaggu.
Nice. Brilliant.
Sorry for that sphere confusion. Every answers are correct. I told it's my view. Sorry.
பரவாயில்ல, it's okay.
Okay, the last one,
Fine.
conclusion. Can I do, Jaggu?
Yeah, please do.
So conclusion. So now we understood depend upon the atmosphere where things exist. So good or bad is depends upon the atmosphere. So everything, including science, must improve the good atmosphere to develop good things. Good atmosphere make living things flying with joy. Beings joy only make the earth safe and happy. Thank you. And I will put the link for the feedback form. You can answer the questions as well as give me the stars. Thank you.
Beautiful. Actually, I loved the presentation. It's like full engaging. It's nicely done. See, almost 30 minutes, but it's totally engaging from the start, even the quiz and everything. Nicely done. Super. Shall we all go unmute and let's give a huge round of applause for Riya?
Amazing presentation.
Amazing.
Give a virtual applause.
Virtual applause. So guys, you can put your
Nice.
feedback in live as well, so that it'll be feels great when we look back.
Virtual applause.
Virtual applause. Okay, nice. Thank you, Riya. Okay, next. Sorry. Okay, yarada. Okay, let's welcome our next presenter. So from Riya's presentation, we learned a lot of things. So we might have generally know about atmosphere, birds and planes. She nicely put it in a such way, right? What is atmosphere? How birds fly? How aeroplanes fly? What is sonic boom? Why some birds fly higher? Why some birds fly lower? So all these things. So this is like a very informative. People who love aeronautics will definitely love this presentation. Thank you, Riya. Next, let me welcome our CTO of Target Space, Darsh Rai. So he is going to
Jagu, he is not the CTO, he is Chief Innovation Officer.
Chief CIO. Okay, Chief Innovation Officer. Okay, both like almost okay, fine. Let's welcome our Darsh Rai. Darsh Rai, the Chief Innovation Officer.
CFO is for financial.
CFO like CIO, Chief Innovation Officer, Target Space. So he is going to do presentation on the topic Newton's 3 laws of motion, and he's from HRNPS Bangalore, grade 5. Darsh, the stage is all yours.
Yes, sir. Now, as sir said, I'm going to present about Newton's law of motion. So now let us begin with the Newton's first law of motion. According to the first law, every body remains in a state of rest or uniform motion unless acted by net external force. But when you throw a ball on the floor, it stops. Why? According to the law, every object will continue to move unless acted by an external force, which will continue to move infinitely, right? Well, no, we cannot see all force like friction, which is also a force. Sir, 1 second,
Yes. I can see that it's clear.
Sir, by mistake I opened the wrong one. Sorry.
Okay.
The presentation stopped. Is it only for me?
No.
No. That one I had. That one actually I had uploaded from my YouTube channel. So
Okay,
sorry.
okay.
Sorry for the interruption. That one. No.
Thus, you can put your YouTube link as well, YouTube channel link as well. I'll put it in a live.
Yes.
Not now, maybe at the end of. So that is the CIO, Chief Innovation Officer of Target Space company, and they are having their group presentation as well.
On.
And this is what we train students, the perspective of why they are learning science. And so that's one of the first.
Okay, sir. Sorry, sir.
No,
So yeah, as I was saying, when you it is due to friction, which is a force. So now let's talk about Newton's second law of motion, which is F is equal to ma, which means force is equal to mass times acceleration. Which means the more mass they have, the more force they require to accelerate. So let's take an example. There is a big dumbbell in front of you, and since since there are more number of mass, it requires more force to accelerate. But there's a small tennis ball in front of you, and it requires less force to accelerate. So it's me, and I'm pushing a small ball, hence less force is required. And it's me again, and I'm pushing a huge block, which requires more force. And it's one of the ways to calculate the mass of faraway celestial objects. Now let's talk about Newton's third law of motion. The law states that for every action there's an equal and opposite reaction. So let's take an example. There's a Newton's cradle and you strike a ball the ball comes back and forth since there's an equal opposite reaction. So, which means in every interaction between two objects, there are a pair of opposite forces acting on each object at the same time. Now, let's discuss about its daily uses, which we always see in our daily life. So, when we sit on a chair, our body exerts a downward force on the chair. The chair also exerts an upward force on the body. This also helps the birds fly. The wings exert a downward force on the bird, and the wind also uh, gives a equal and opposite force which helps the birds to fly. So now let's summarize everything. So Newton's first law: every body remains in a state of rest or uniform motion unless acted upon by a net external force. Newton's second law: the amount of acceleration of a body is proportional to the acting force and inversely proportional to the mass of the object, which is represented as F is equal to ma. Newton's third law: for every action there is an equal and opposite reaction. Thank you.
Nice. I think this will be useful for all the students who are watching, because it's one of the major basics which needs to be understood to do any physics or anything related to engineering. Nice. Yeah, if you have any questions related to these three laws, you can ask Darsh. I think all of you might be learning this as well in your physics.
அண்ணா கடைசியா ஒரு பிக்சர் காட்டுனீங்கல்ல தேர்ட் லாவும் ஒரே பிக்சர்ல
What? Can you speak a little louder because I can't hear you?
Once again, share the presentation.
The last image you showed, right? You wanted to see that.
Okay. 1 second.
Darsh, is the animation everything done by you?
No, sir. From Google, I found some gifts, sir.
Okay. Nice.
So I decided I will use them.
Nice.
So that so that you can understand more clearly.
Got it.
And you don't have any doubts.
And he wants to see that, I think the last.
Okay. One second, sir.
Yeah. Jagu.
Yeah, this is the slide. I just put it like some apple fall on his head that everyone will learn in their physics class.
அண்ணா இதுக்கு முன்னாடி வந்து
Before this.
Okay, sir. This one, right?
Yeah, I take the screenshot.
Okay.
Yeah, I take the screenshot.
Okay.
Nice. I like the Newton's apple falling picture.
Yes, sir. I put it, sir, because I heard that everyone in the physics class will learn that the apple fall on the head, sir.
Yes.
Yeah, I also learned.
Nice. Darsh, you have quiz for them?
Yes, sir. I have quiz, sir. I will upload the link, sir, but it's not allowing me to send to everyone.
No, just okay. Oh, sorry. Oh, I need to change it. Oh, okay. Now you can.
Okay, sir. Now I'll upload this link. Yeah, the link.
I'll put it in live as well.
Yeah, I'll screen share. 1 second, sir. I will close. Yeah, here.
Darsh is time based.
1 second. Sorry, sir. That is the wrong link.
Oh, okay. Just send me that.
Yeah, again I sent.
That's the correct link.
Yes. Yeah.
Darsh, you start.
No, everyone should join, right?
Let everyone join. Okay. Posted it.
Jaku,
என்னப்பா
இந்த quiz game create பண்ணனா நம்ம quiz app download பண்ணணுமா?
Another
You
Satyagiri.
just have to.
Yeah,
You just have to
We
sign in.
should, yeah, we should sign in. We need to
Yeah, you need to
download
sign in.
and sign in. Then you
I
can
don't
do
have
Yeah.
to download because I have not downloaded.
Yeah, you don't have to download, but you need to log in.
Yeah. No, you don't need to download. You just go to your web browser, type quizzes, and log in. It will automatically log in. And
No,
if you open
just
in
click
the
the link.
future,
Yeah,
it will open.
Just
Yeah.
click the link, guys. That's all.
Yeah, Darsh and someone joined in a name called Space Eye. Who's that?
Yes, yeah. Yes, so I don't know. Maybe
Yeah,
some
who?
people from YouTube.
No,
Yeah.
Not YouTube.
I
That's a
think it
company
may
name.
be
Maybe I
Himesh.
guess
or-
it's I don't know.
We'll start that quiz.
The should have started because 14 people are
Jagu.
joined.
Okay,
Jagu.
start.
Okay, Jagu.
Okay, now let us start.
Amrit also here.
So, who is the scientist that developed the law of motions? Okay, so now let us go to the next question. Sir, is it visible?
Yeah.
Okay, sir.
Darsh, can you show the leaderboard?
Right now it will not show because
5 more
Okay.
seconds. 5 more seconds.
Yeah.
after this question will get over, it will show. Yeah, you're in this. You're the leader.
Yeah. Vignesh is leading.
Yeah. Yeah. So now let's go to the next question. So the question is, which law is used to calculate the mass of faraway celestial objects? This is fill in the blanks.
Which law? Is one of the 3 laws?
Yes, sir. In the, what I told. Yes, sir. One of 3 laws only, sir.
We want them to put the
So I have to type it.
answer.
Hey, Darsh, it's wrong. You told that F is equal to MA only, no da.
1 second.
Hey, that's
Newton's second law at put.
second law is correct. Everyone we wrote second law only.
But
You may not have had a law. You may not
Second law is the
have
answer, right?
Newton's second law.
Yeah.
Typed second law. I didn't even type anything.
I just wrote second and I got it correct. I don't know why.
Yeah.
I just
You
wrote
have to write it correctly. Newton second.
Darsh, put
Yeah,
MCQ questions.
yeah, and
I just put Newton's second law because I thought this is like the most like logical.
That's okay. Nice. Next. What stops ball in pitch?
Yeah, and for the sentence you don't have to write. You just have to write one word answer.
you gave the half of the word. You were reading the sentence.
Without my knowledge object.
What?
No, nothing.
You gave a hint for the word. I don't think people heard.
When these many people are not answering.
You're thinking.
Okay, so the answer is friction. So now let's go to the next question. Like this one, I like not wrote in presentation, but like it's like logical question.
Yeah, application based.
Yeah.
All the lawsuits. Let's see.
Hello.
Yeah.
வாங்க
Ajit.
அரிஜித், வருக வருக நான் வரவேற்கிறோம்.
Leaderboard. The third law was the correct answer. And if you want the explanation, it is every action has an equal and opposite reaction. So like when you're putting the seat belt, there is an force which is pushing, which is pulling us back side. So that is the correct answer. So now, which law explains why heavier object requires more force to be moved? This one is not fill in the blanks. It is
Very
options.
straightforward question.
Yeah.
Actually, so leaderboard, not showing you.
Okay, I'll show the leaderboard.
People did not.
No, he's just like
You need
pressing
to wait for
OK
6 seconds.
No, he's just going faster.
Okay,
So that's why we are not able to see the.
Leaderboard. Yeah, now I guess so leaderboard will show.
You click.
Don't
You
click
so
there.
it showed this
Don't
thing.
click anywhere. Do next
Yeah.
question. It's the last question, and just do next question.
Next
Okay.
question, then you
Click.
you can.
This is our last question. So
Yes.
Yeah.
yeah, so now the leaderboard will come. Slow. Congratulations, Rian, you're the winner. And sir, you're also attending.
I am only third.
Who is the third?
The third is
Satyagi,
Isha, Santana,
Sadhana,
and
Sadhana.
Sadhana.
Shadana, yeah.
Sadhana, okay, sir.
Yes, the third question before I typed, it just went off. Nice. Well done, Riyansh. Well done, Sadhana. Well done, Satyaki. So don't consider me in this line. So it's Riyansh, Sadhana, Satyaki. Well done. Awesome.
Who is that Jaggu?
Jagu. I am Jaguda.
Okay, sir, you are attended.
Yeah.
Get the quiz down.
Nice.
Okay, sir. So
Thank you, Raj.
so
Why
hope
today you didn't attend for reactions?
Yes. Oh, yeah. Okay. So, Darsh, I like it's a very simple presentation, but you looked at the quiz, it's all logical. So those who are preparing for IIT, JEE kind of computer exam, most of your questions will be like logical.
yes, sir, I have been logical little.
Yeah. So think in this perspective, you will crack any exams, like any competitive exam. It's not like. So what Darsh is going, this method is very nice. Well done, Darsh.
Thank you, sir.
So let's give a huge round of applause for Darsh. Super presentation. Even though it's a basic topic, it's like it's nice, and the way he put it up in the quiz.
Amazing presentation, Anna.
And Darsh, you have
Thank
put your YouTube channel link in your
Okay,
chat
sir.
box as well. I'll put it in live as well.
Okay, sir.
Yeah.
1 second, sir. I will. So the video link,
No, yeah, channel link, video link, anything.
Okay, sir.
Yes, sir. You need to do it.
Always subscribe your channel.
Yeah, the link is here.
Nice. So let me post this link in.
I posted in our Isha group.
Yeah, put it, please tell them that this is Darsh channel, an educational channel for students. Just subscribe. There are like I think more than 50-60 students, right? Yeah. If all 60 can subscribe Darsh, that will be great. Nice. Okay. Well done, Darsh. Okay. Next, welcome our CEO sir of Target Space, our Vignesh Anirudh. So Vignesh Anirudh, he is from Chettinad Vidhyashram grade 5, and he is going to present one of the advanced topics that we are doing research in Vaayusastra as well. That's about antennas, and he's going to do something on antenna trajectory. I would love to hear more about antenna trajectories. Vignesh, the stage is all yours.
Thank you, Jagu. So now I'll start screen sharing. Hello, everybody, and welcome and good evening. So it's me, Vignesh Anirudh, and today I'm going to present on the topic antenna trajectory. So an introduction about me. So I'm Vignesh Anirudh, and today I'm going to present on the topic antenna trajectory. So I'm the CEO Vignesh Anirudh H, and MD is Harjit S.
I am mission director, bhai.
Yeah, mission director.
Jagu, I just put the music. I'll just screen share it again.
Yes, yes.
1 minute, Jagu.
I'm just sharing this group link all in the
1
space.
minute, Jagu. I'm just sharing it.
Yeah. Take time.
Yeah, Jagu. It's just my computer had been hanged, so I'm just recovering that.
Okay.
So let's say first of all an antenna trajectory overview. So antenna trajectory resonates from a signal. So there are two types of signal, the analog signal and digital signal. So let's say first of all basically what is a signal? Varying voltage, current or electromagnetic waves that carries information any time is called a signal. So let's see first of all what is an analog signal. So analog signal basically will look like this as here shown in the image, and analog signal is produced by a law called Faraday law. Faraday law is basically a law when you put the coal and when you put the magnet inside and take it, it forms an electromagnetic wave. So that's only basically a Faraday law, and this only analog signal can be produced. So let's see first of all what is a digital signal. So digital signal will look like this as I have shown in this image, and digital signals works 0101. So you may ask, I'll explain it to you correctly. When in your house will have a switch. Okay, when you on it, the light will on, and when you off the switch, the light will off. So basically the signal will be produced by a rapidly flipping switch. So like this, it will be produced in an antenna. And so let's see signal. What in signal is based on whichever things. Basically signal is based on three properties. They are frequency, wavelength and amplitude, and they look like in the form of electromagnetic wave. When these three, where frequency it will have the whole power, and wavelength will show the distance between each, and amplitude, no, it will show up to down. So basically these three forms an electromagnetic waves. And let's first of all see what is a frequency. Frequency is the number of time in a specific intervals occurs within a specified time interval. So basically we can take an example. If you take your birthday party, it comes every times once in a year. So what do you mean by that? The frequency is birthday party comes once in a year, and it's measured by a unit called hertz. So let's see first of all basically what is hertz. Number of cycle per second. If we tell like this, it will come up down up down up down. So I will now give an example. For an example, Indian electric speed is 50, just for an example. So when we do like this, it will come 50 times up down up down up down. So it's basically measured when it come up down, 1 hertz has been finished. So like that only, then but the number is 50 hertz. So let's go to our next slide. So let's see first of all what is a wavelength. So wavelength is a number of waves that pass between the peaks and the troughs in a certain point in a specified amount of time. So basically the wavelength will run between peaks and the troughs, as you can see in this image, like this. So the properties of this wavelength are peaks, troughs, and it's measured by a unit called lambda. So let's see first of all what is a lambda. It is equal to the speed of a wave in a medium divided by its frequency. So now we'll be seeing about amplitude. So what is first of all an amplitude? Amplitude is a maximum displacement which runs from the peak to the trough, and it's moved by one vibrating body or wave measured from its equilibrium position. And 0 is equal to equilibrium position. So you may ask if all will have same size only. All you may ask in an electromagnetic waves, the length different every time, the amplitude is same, but frequency and wavelength are different, and properties of this amplitude is peaks and troughs. It is measured by a unit called meter. So let's see what is first of all a meter. A simple meter matrix is called a meter. So let's see few facts. So only radio waves and microwaves can be used in an antenna. You may ask, how this boy is saying like this? You may ask, you will have some questions. So I will just answer that. So when there is low frequency and high wavelength, the signal can travel for a long distance. If you take radio waves, microwaves, and gamma rays and X-rays. So gamma rays frequency is 10 to the power of 18 and X-rays is 10 to the power of 16. And radio waves is 10 to the power of 6 its frequency, and microwaves 10 to the power of 8. So both we have taken but gamma rays and X-rays has more frequency compared to a microwave and radio waves. But gamma rays cannot cover a single atom. Basically, it cannot cover a single atom. So in gamma rays, there will be low wavelength in gamma rays and X-rays, but radio waves and microwaves will have high wavelength. So radio waves and microwaves will have high wavelength and low frequency, so they can be used. So it's especially a point which I can tell it understandable, which is I just explain it to you by understandable, but I'm going to give in a single point saying that as microwaves and radio waves has high wavelength and low frequency. When there is higher wavelength and lower frequency, the signal can travel for a long distance, because in gamma rays and all cannot cover a single atom. You may ask, how is the frequency possible? Because when it's so small, the wavelength, then the frequency will be high. And when microwave will have higher wavelength, the frequency will be low. So microwaves and radio waves can only be used in antenna. And wavelength and frequency are indirectly proportional. Why? The same question will come to your mind, but now I'll be telling the answer. For an example, if you take a microwave and gamma rays has high frequency but low wavelength. But microwave has high wavelength but low frequency. So in this we have understood that the wavelength and frequency are indirectly proportional. So does anyone knows who is this person? I don't need to be interaction. You need not to unmute and say, just type it in the chat.
Yeah, some of them have started telling the answers.
Isaac Newton.
Yes.
Jagu, ask them to type in chat box.
It's okay, it's all our teammates.
Newton.
Yeah, Isaac Newton is the correct answer. Isaac Newton is our correct answer. So how did he form that? So after he founded the gravity and laws of motion, he was sitting down the train thinking. It's just a basic story. When he thinking, he has a question on his mind saying that why moon didn't crash on our earth? if then he told that we have founded the gravity. So with the when the gravity is all over our solar system, the moon will definitely fall on Earth, and each planet will crash. Not only Earth, all the planets will crash. So he started writing the formula. He had written a Newton's third law, which is for every action there will be an equal and opposite reaction. With this law, he wrote a law called universal law of motion. So he basically understood that his questions are where it is located, where is the gravity ending and located. So he got the answer as, if we take mass 1, which is our Earth, and mass 2, which is our moon, and F1, force 1 and force 2. So both of this meet at a single point. There, the gravity will be so the gravity will be at the center, and for every action an equal and opposite reaction. So both of them will be kept in the same place due to this high force. And for an example, if from our Earth, okay, this is our Earth, from here if a rocket goes to moon, here in this line the rocket will be in high speed, and it will track off the Earth's atmosphere, and it will reach the moon's atmosphere. But some people may ask that, is gravity on the moon? No, yes, but in moon, as if Earth, there is less gravity. In moon, the gravity is 1.62, but in Earth the gravity is 9.8, so it's lesser. So when the Earth crosses the gravitational layer, which is located here, it will go into moon's atmospheric controlism, and it will reach moon. From moon, if it travel in a high speed, when it crosses this gravitational layer, when it reaches our Earth, it will be absorbed by our Earth atmosphere. So basically this formula is a simple formula. So his question answer was correct. Where it is located, he got the answer. It's center between a moon and Earth because of this force. So this formula is a formula I've now explained is F1 is equal to F2. F means force, and F1 means force 1, and F2 means force 2 is equal to G means gravitational force. M1 multiplied by M2, mass 1 multiplied by M2 divided by R square, or you can tell D square as divided by D square. Both are same only. So let's see basically how can a signal travel. So after this, Newton got an idea. We have seen where it is located, but how can a signal especially cross that line? So Newton just not think the signal, he think also for rocket, spacecraft, etc. Okay, so but this is only about signals, so I'm explaining about signals. So in the Earth, inside the Earth, the signal will travel through air, and when it comes to space, radio waves can travel through space, and electromagnetic waves will transmit more energy through a vacuum. Once the radio waves receive the signal, it can convert the signal into sound, which travels through the air in your spacesuit without a problem. And when the signal crosses the gravitational layer, so the gravitational layer will be so extreme, so it will be pushed from the electromagnet. The electromagnet will be transmitting more energy than normally we are going in space. Than that, it will transmit more energy than normal. So let's see the principle of an antenna trajectory. The antenna and the transmitter generates the radio wave. A voltage at the desired frequency is applied to the antenna. The voltage across the antenna elements and the currents through them create the electric and magnetic waves respectively. Thus, the antenna becomes the source of the receiver input. So let's see basically the transmission of a signal. So basically in transmission, I would like to add one point. When a single antenna and multiple satellites join, it forms an antenna. It's called as antenna arraying. And it's called an antenna arraying. So now let's say basically if we stop an antenna, as you can see in this image in our Earth, and if we put and a satellite is flying, so basically don't think this is an antenna, it's a high gain antenna. Okay, it's In Earth antenna only, in Earth there is an antenna, that's only normal antenna, and the satellite there is an antenna. Okay, it's also known as high gain antenna as well. So there are two parts in these both antenna, which is the receiver and the transmitter. Receiver means when the antenna receives the signal in the part is called a receiver, and transmitter is basically a transmitter is it will transmit the signal to another antenna is called a transmitter. So if we, for an example, if this is a Earth antenna, here in the transmitter, from here a signal is traveling to the satellite, okay, in a high gain antenna, and receives here, and it will produce a signal again to Earth antenna, and it will be producing a high gain antenna to a transmitter and will receive here in receiver. And how it comes in the form of analog signal, as I told in the beginning, and it will be stored and it will be shown in our Google. If we type Mars, it will show the Mars image. So it will come like this. You may, for ISS also the same process had been used. For any satellite, any spacecraft, this technology had been used. So now it's quiz time. Before the quiz time, I would like to end my presentation. So thank you everybody. And in my next presentation, we'll be seeing about how can we measurement of an antenna trajectory, and another Newton's story is weighting. Okay, that's so that we now saw where it is located. How can we measure and tell where it is located? It's basically it's in a max called as calculus. That will be in my next presentation. Thank you. Please share your feedbacks and suggestions.
Vignesh, this is where a level. This is like whatever I learned in my college second year, third year, even I think 11th, 12th, we have some bit of it, all this frequency, amplitude, vibrations and all. But in my college only I had detailed topics on these. So you have any questions you can ask?
Yeah,
Vignesh.
doubts.
Yeah, so Vignesh, one thing I would like to tell you is this section you could have kept it a bit at the frequency and amplitude part. Could have kept it a little interactive if you, so it would have looked a bit better, and you would have also like felt it engaging sort of. So I'm not asking you to put that antenna transaction on one part in interactive session, but the amplitude frequency, people of 7th, 8th, and 9th must be knowing about it. So if you had kept it a little bit interactive, it would have been much better and engaging as well.
See, Riya, I would not like to keep it interactive, because in sometimes if some people will mistakenly unmute and some noise will come. So I basically in my PPT I will not keep interaction. That's the only main reason. But
then people will get bored and people will not like your presentation. In a presentation, you need to keep it engaging. Presentation is you engage the users. You don't speak. You engage the users at a presentation.
Nice. Anyway, it's okay.
Yeah,
That can be
but I don't like to keep interaction, because sometimes
no issues. No issues. As long as the content is neat, okay.
Okay, Jagu. So thank you. And
nice. We have Harijit. Question from Harijit. Harijit, you can.
What question, da?
My question is that somewhere you said, right, why in the Newton was thinking of why the moon is not hitting the earth.
And you have understood it wrongly, da. It's wrong. See, when he is sitting down, that he was thinking that as why did the moon crash on it? The earth is not eating the moon. Okay.
Okay. Anyways, okay. But and I like that, and think, and after only he was inverted gravity, you said, right?
Yeah. After he.
But wait, there's by apple tree, that story is there, right? apple.
Yeah,
He understood
yeah, it's a wonderful story. I just got this ideas in YouTube. Okay, after he did that, no, I just saw. Every time in my night, no, if you need to see cartoon, I'll just see scientist videos. That's all, Jagu.
Nice. So that's the thing.
wait a
What
minute.
is,
Wait a minute. I asked the question that you are saying because of apple tree stories, that one he invented. But you are saying
After that only he invented. I'm not telling during that time he invented. Okay, I'm telling after that only he invented. I mentioned that word.
yeah. Okay.
the Newton came up with this thought experiment called Newton's cannonball experiment.
Yeah, after he just rode an apple, it fell down, and he started the cannonball experiment.
Yeah, that. Okay. And actually, I like the presentation. It's very neat. Detail it very much in detail, and it also helps your school studies as well. Because students who are in grade 8, 9, you must be well aware. Like you are getting introduced to these topics. I think last week we had a presentation on magnetic river. I think.
Sir, you had presented that.
Yeah, I did.
After the live stream had got over.
Yeah, after the live stream got over. Yeah. That Jagu, that is only I told Vignesh. He should have. He could have. It's his wish if he doesn't want to give it interactive.
Yes.
But he could have if he wants. Yeah, he could have.
Yeah.
But
We will have one more session on the same.
I did not like this interaction because
Okay. That's fine. Okay, now quiz time.
Point taken.
Point taken.
You don't want it, don't do it. I just give you a suggestion.
Yes.
I didn't know if you like it or not.
Quiz time.
Jagu, if group chat is there. I just send it to you personally.
Yeah. I'll share it. So, Vignesh, I'm like very happy to see this presentation. This is very, very nicely done.
Okay, Jagu, thank you.
And I know how hard your team is working as well. So nice. I'm looking forward for the team presentation also tomorrow.
Yeah, Jagu, tomorrow we are presenting.
Okay.
Jagu, this is a small quiz only, not big and all.
No issues.
Jagu, shall I start?
You can wait for at least 10 members to.
Okay, Jagu.
How many joined? 7. Okay. 8, 9. Okay, one more. If they join, we can start.
Jagu and request unknown user names.
That's okay. I think all are here. All are only people in this group. You can start now.
Okay. On your mark, get set. 1, 2, 3, go.
Okay. Just put full question here.
Full question. You can also repeat question. Full question.
Vignesh, can you remove that music?
Okay.
Which music?
Yeah, there's a background music going on.
Yeah, what usually comes.
Okay. You can mute it actually.
Can you hear me?
Yeah. Put
Yada.
question here. Put
Here is one speaker, no speaker here. Just click it and reduce the volume.
Oh, where is that? Jagu, shall I show you the?
Down. In speakers.
Hey, one more person to answer.
by birds, lambda, kilometer.
Easy.
Let's see who is the winner.
Yeah, all of it. Nice.
Leaderboard. Ranadeep Reddy is leading, followed by Amruda and Jagu.
submarine antenna is used in? Satellite, rocket, earth, all of this.
All of this.
Hey, don't tell the answer now.
These something else after now.
Arjit only told Jagu. The leader is Ranadi Prenali, followed by Amrita.
Yes, I the one reason.
Oh, sorry. Previous slide.
Rida. Any presentation?
Vignesh, can you ask that music that here and that music this thing just mute it?
How can we mute that?
Here is one speaker option in that.
Down. See down, Vignesh.
Yeah, I can see it. Volume off.
Put text da.
Text.
Put the text.
Let's see who is the winning. Ranadi Pretty, followed by Amrita and Anish Noel.
Who's no mask?
Archit, can you be in mute that because you are telling the answers?
Yeah. Okay, I know this. I'm not saying.
Yeah, this is very easy da.
Actually, I cannot attend. On the reason I'm quite asking if this is start
Neither would da.
Ranadi Pretty is still reading, followed by Amrita and Anish Noel. This is our next question. Adrit, finished. Finish. Okay, let's move to next question. Adrit finished. Yeah, next question. Yes. So let's see who is the winner. So the winner for the day is Ranadeep Reddy. Awesome, Ranadeep Reddy. Jagu, can you hear me?
Yeah.
Yeah. So
Ranadeep Reddy, Amrita, and that's Riyansh.
Basically, Jagu, Amrita, I think so, had been done less time. But Riyansh had done 2 mistakes.
Yeah.
And Anish Noel, Bhairavi. But Jagu, I'd like to add Amrita and Ranadeep in the first place because they got all the questions correct.
Yeah.
And the second is Aerospace now CTO Riyansh and
the timer length benefit.
Yeah, and fourth is Anish Noel and Bhairavi Karthik Bhairavi, and that's all, Jagu. The game. That's all.
From next week, I think we will have a few new presenters as well.
Yeah, Jagu. In the Varo Monday team, tomorrow we are presenting team.
Nice, nicely done, Vignesh.
Department.
Thank you so much. That's a beautiful presentation followed by nice.
Thank you, everyone, and thank you.
Well done. Let's give a round of applause for Vignesh.
Thank you, everyone, and thanks to Vaayusastra for encouraging.
Amazing presentation, Anna.
me.
Okay, thank you, Anirudh. Okay.
Jagu, it's not Anirudh, it's me, Vignesh Anirudh. Yeah.
Fine, Vignesh Anirudh. Thank you. Okay, next, welcome our next presenter. Bhairavi. Okay. So she's also from team Target Space and she's from Sreevatsa Viswanathan Vivekananda Vidyalaya, grade 6. And she is going to present on the topic time travel. Bhairavi, the stage is all yours.
Sir, can you see my screen?
Yes.
Yeah, okay. Thank you, sir. Hello, everyone. I'm Bhairavi, and today I'm going to present about time travel. So the topics to be covered are: what is time travel? Is it possible to travel back in time? Can a time machine be invented? What is the purpose of time travel? And can a time travel change the past?
In the last question, topic last I had this fifth one. I had this also. But I went to what is that?
1 minute. So, what is time travel? Time travel is the idea of going back in time to the past or forward to the future. We always travel forward to the future. Time travel to the past is not known to be possible, but it is much used in fiction. So, is it possible to travel back in time? Although humans can't hop into a time machine and go back in time, we do know that clocks on airplanes and satellites travel at a different speed than those on Earth. NASA's space telescopes also give us a way to look back in time. So, can a time machine be invented? Time travel may soon be possible, according to an astrophysicist who believes he's worked out a way to build a time machine. Professor Ron Mallett from the University of Connecticut in the US claims to have written a scientific equation that could be used to create a device that takes people back in time. What is the purpose of time travel? They often provide some sort of social commentary, as time travel provides a necessary distancing effect that allows science fiction to address contemporary issues in metaphorical ways. Can a time travel change the past? Time travel cannot change the past. They cannot make it different from the way it was, but they can participate in it. They can be amongst the people who did make the past the way it was. So thank you everyone. I have a quiz. You can join the quiz by going. Yeah.
I will show how can we the second slide after what is time travel?
Yeah. Okay. Is this the slide you're asking?
Yes.
Yeah. What doubt do you have in this?
Actually, we can travel back in time, but can we travel back in time as far so that before the world is created?
I understood your question, but no, we cannot travel as back before the world is created.
Now I can ask my doubt.
Yeah.
So in last year have been mentioned that NASA's space telescope also give us a way to look back in time. I don't understand how a telescope can give us a way to look back in time.
Like, how do I say that?
Hello?
Hello?
Bhairavi,
Yeah.
in which app do you do this presentation and just asking?
No, I don't understand, Anish.
No, in which app are you doing this presentation? Canva, okay.
Canva. It's like something little bit.
Yeah, Canva.
Can you, Bhairavi, please answer to my question. NASA
Yeah, Harjit, I don't exactly know the answer. I'll answer you in the chat box. Okay.
What is the question? What is the question? I'm sorry.
NASA's in last night she have been mentioned that NASA space telescope also give us a way to look back in time. How a telescope
Okay,
can
that is, so NASA basically collects information of light. So there's nothing but light, which is like, that light is not created within seconds. That can be with 13.5 billion year old light, which traveled. So whatever you are looking at currently is something past. Got it? So whatever you see through telescope, it is not happening like within like 1 or 2 seconds. It happened few billion years ago or few light years ago. So any light that reaches us some very far, Andromeda, do you know how far is Andromeda galaxy? Anyone just tell? I think it is like 20, I think it's 2.5 million, I guess 2.5 million light years back.
2.537 million light
Yes,
years.
exactly. So it means that light traveled that many years to reach our telescope. It means you are looking at the image, which is like 2.37 million years back. So you're basically looking back in time, right?
Yes.
So that line explains that one. NASA space telescope also give us a way to look back in time.
Jagu, I just have a doubt.
Yes.
See, but some scientists like Albert Einstein and Isaac Newton saying that time is not there in space. It's only there on an Earth. Like saying that 2 o'clock, 1 o'clock. So, for an example, if we take India and Britain, no, Britain is 4.5 hours back to us, and we are 4.5 ahead to them. 1 minute.
Whatever you are saying is right. This is the time is created for human understanding.
So
Yeah,
I have
actually
from
we can
this sentence 1
actually we
minute.
can time travel in time
There's
theoretically.
1 minute. So from this thing, I have a doubt. Like this, no, in our Earth, when they, for an example, India time is 9 o'clock. What is the time in space? I need this question, the answer for this question.
What is the time in space?
Hey, this question is not related to.
Yeah.
Yeah, it's related. Okay, it's related. Yeah, if in the Earth,
This is time is only for human understanding, basically.
Yeah.
But
Time
the
is
topic
not,
is time travel, no? So this question.
time travel. We have named it time travel. It is not specifically that it is.
That's only a theory.
Time travel.
Yeah, I just have this.
Only a
Nice,
theory.
nice. Whatever you say, yeah, it's like the time is maybe, yeah. It's our understanding, our brain.
Actually, we could theoretically do
Jagu,
time
but some
traveling.
person have sent that 163 53 566 826 36.
I guess we're staying at time and space. I guess we're
But see, Bhairavi, I need this question answered. Okay, because it's
Jagu, first of all, நான் வந்து quiz வந்து players join பண்ண நேரத்துல தானே doubt question போயிட்டு இருப்பா.
Yes, sir. Can you send the link, sir?
Yeah. Put Bhairavi.
Yeah, I'll send the link.
Bhairavi, just
I'll send the
answer
link.
this
Okay.
question, okay? Because this is also based
See, the
on time travel.
quiz link is not there yet.
Okay.
Yeah.
Jagu, I have the doubt. Can you ask Bhairavi to answer that? Because the doubt.
Vignesh, please ask that in
Yeah, put it in chat box. No, put it in chat box.
But okay, I will ask that.
Anish also has a doubt. Yeah, Anish, you can put it in chat box. Now quiz link is up, so I can put this. Yeah, the first part is the quiz link.
I'll share the screen.
Okay, I'll put it in YouTube live as well.
Bhairavi.
Yeah.
There are many people in the. There are 11 people. Please refresh.
Yeah, okay.
See, that's all.
I'll start the quiz.
I could start.
என்ன
Riya is leading.
Bhairavi can read out the questions as well.
Yes, sir. So the first question is, do you think time travel is possible? The options are yes, no, maybe yes, maybe no. And the second question is, time travel to the dash is not known to be possible, but it is much used in dash. The third question is, according to an astrophysicist who believes he's worked out a way to build a time machine, dash 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 from the University of Dash in the US claims to have written a scientific equation that could be used to create a device that takes people back in time. So the options are Professor Ron Mallett and Dr. William, and for the second fill, Tennessee and Connecticut. So this question is like rating my presentation. The fifth question is, clocks on airplanes and satellites travel at a different speed than those on Earth. True or false? And the sixth question is, read this and form the question. Time travelers cannot change the past. They cannot make it different from the way it was, but they can participate in it. I think everyone is almost done.
Bhairavi, I have a nice news for you.
Yes, sir.
Finish this.
Okay.
Your news is up in the Provoke magazine. There is, I'll put it in our group.
Yeah, okay, sir. I'm going to end the quiz in another minute. Who's this person? Okay, I'm going to end the quiz. I ended the quiz. So Darsh is leading. The second is Vignesh Anirudh. And the third person is Riya. Followed by Matish, Tandeep, and Riyansh. Okay. This is the toughest question. Okay. This is the longest question. Yeah. Okay. I'll stop sharing.
So quickly show the one page of, it's a 3-page article. In that there is a mention about Bhairavi's work.
Oh.
I will show you now.
Oh.
Correct, just now I received this. Can you able to see the screen?
Yeah, sir.
So, okay. Can you share an impact story of Vaayusastra? Recently, I was teaching our students how to access Chandrayaan footage when I said, a student of class 4 that I told of 4-5. By the way, made a really good presentation. After I casually mentioned about making her work in a book, she began working on it. At her 400-page book is in the process of getting published. So this is an Provoke lifestyle. So this week it's getting published. I'll share the PDF in the group.
Yeah, sir. My God. No.
Nice, well done, Bhairavi. Even though it's a short presentation, and this presentation is this time travel is always a confusing topic, no? we never know whether to take the time travel or traveling back or future. Yes. So nice. Let's give on all of you unmute. Let's give a huge round of applause for Bhairavi.
Amazing presentation, Akka.
Thank
Raghu,
you.
but I have one
Super
feedback.
presentation
Bhairavi,
and congratulations
Yeah.
about your
Bhairavi,
Yeah.
the PPT is very good, but it's literally confusing me this time travel, okay? In space and in Earth. So you need to research for that.
Yeah,
So
yeah.
it's not awesome, but very good. A good job.
Vignesh,
Because-
time travel is confusing the way how you understand it.
By itself, it's a kind of.
Vignesh, you have been understand.
Not blame. You
Wrong.
cannot
First of all, CT of aerospace now. First of all, time travel, this is a basic question, okay? And I'm not telling that Bhairavi had done a bad job. Good job, but she need to research on that.
Yeah. Okay.
You need to research also, but Vignesh, time travel is also a topic which you need to interpret by yourself.
Yeah.
You also need to interpret time travel by yourself. It's not only Bhairavi or the speaker who can do it. She needs to research, no doubt. She needs to research more in
Okay,
detail.
but I'm researching in different things, okay? Because
Okay, fine. The time travel itself is a kind of twisted topic only. Don't worry. I'm just waiting for Himesh.
Can repeat your question?
Yeah, the question is, in time travel, this is an important question. Saying that as if for an example, if in India the time is 9 o'clock, in Britain, okay, the time is 4.5 hours backward. In Britain, the 4.5 hours is forward in India. So basically in space, okay, when in Earth it's 9 o'clock, in space, what is the time? So that's a basic question and time.
Vignesh, I want to. I can answer
No
this.
time and space.
What?
I can answer this question.
Yeah, Harjit, answer that.
That is for this question. It is not related to time travel. First, I will say, and you are asking what is the time and space. And she told time travel. Okay, asking what's the time in that place. That the place is space. But she's saying about traveling. So this is not related to her presentation.
It's related, that means
Vignesh,
this topic we are speaking about space. So
Yes, for
this
this
content need to be answered. Okay, but
Vignesh, listen,
no worries, Bhairavi. Your
Vignesh,
PPT
I
was
am
nice. You
asking
can
a
answer this question.
Vignesh, I'm answering your question.
Hey, Jaggu, I don't want to go for a fight. Jaggu will answer for this question.
Are Harjit, I'm answering. No, let.
Yeah, tell. Yeah.
Here, I was answered, Jaggu. Jaggu, I was answered fully.
Time
Vignesh did not understand what I'm coming to say.
Vignesh,
Jaggu, please tell that how he can understand that way. You should say, Jaggu. He's asking in different, there is 4 hours different.
Hey,
In
but
India,
I think you
suppose-
are not understand my question because
Arjun,
when
wait.
for an example only I told, okay, but when Earth there is a time, for an
Vignesh,
example in
can I
Earth
answer
which
your
is
question?
9 o'clock in space, what is the time?
Yeah, wait.
That's my
Vignesh,
question.
Wait, Riyansh, tell Riyansh.
Yeah, see, first of all, for any clock to work, you need gravity. You need some amount of magnetic field. But in space, you don't have magnetic field nor gravity, nothing. So there is no time and space. And why is you asked that why the time in Britain and India is different? This entirely is our understanding. We have divided the earth into longitudes, latitudes, and that the entire geography thing. You need to learn about this geography and everything like that. And then it is because one more you have to you need to for latitude longitude you need to learn geography. You need to come detail into geography. Yeah, Vignesh.
Okay. Vignesh, okay, unmute.
Okay, Riyansh, but we need to find that. So Bhairavi and me are going to research on that and till in next PPT.
Yeah,
Yeah.
that's not.
Yeah, Jagu, yeah.
You can do that.
I'll be presenting that on November.
Beautiful. Nice. So I just locked the dates for the whole year. I think so soon it will happen because we got full for almost next week also it's almost full. Already slots are full for presentation. And we got 2 new presenters, most probably Amrita and Jason will be presenting next week. So let's see. So you'll have a lot of new teammates. Tarun also is interested in presenting. Tarun, I'm waiting for your topic and details. Okay.
It was next week, sir.
Yes.
Jagu, please just can you put the how many slots are available? Sir? According to that, I decide my presentation.
Yeah. And what?
Just put how many slots are available.
Yeah. Yes.
So that I can plan my presentation according to that.
I'm waiting for Himesh. Where is Himesh?
Himesh is
Yeah,
not.
Jagu, Himesh is not there.
Last week also he told he's going.
Yeah, Jagu, better he can end his live stream.
Yeah, wait. So maybe till he comes, maybe I'll show this magnetic levitation.
Yeah, Jagu, you can show.
So this is one of the presentation I did for Hindustan College Faculty Development Program for the faculties.
Super, Jagu.
Some Jagu, great job.
Hey, that's not great job. What I'm showing is you need to understand.
Yeah, Jagu, one day I saw that
Because
video.
this topic is called magnetic levitation. If we learn this magnetic levitation properly, the space travel the cost will reduce to $50 to $60 only. With $60 you can travel to space. You want to know how? There is a thing called
Jagu is the PPT for that.
Yeah, there is. I made some.
Can you share, Jagu? Can you share and explain?
Jagu,
Yes. So this is the PPT I made. And we also
Jagu,
made
some noise is coming. Background noise.
என்கிட்ட வரலப்பா எனக்கும் கேக்குது யாரோ பேக்ரவுண்ட் வாய்ஸ்
Where is the full screen option? So first I started off with what is magnetic levitation, how is our imagination. If you have read this book called Gulliver's Travel, they mention about this floating or levitating island.
Yeah, levitating island. Yeah, correct.
Then it comes
Yeah,
in.
Jagu, this year I had that story in non-detail.
I had to read the entire novel.
Yeah.
So
yeah, I know the full.
Me too. I have a whole book of.
And also the movie.
Yeah, I have one whole
movie.
book of Gulliver's story, and they're teaching in my school as well.
Yes, also the movie. Also the movie.
Then there is Spider-Man comics also has some amount of. Then Indian this mythology. There's a temple called Somnath Temple. The Linga, the thing.
Kona temple.
which was actually which was like a floating linga.
Jagu, I have.
Temple பேர் அப்படி சொல்லுங்க. Temple
Yeah,
பேர் என்ன?
Jagu.
Somnath,
Where is
Somnath
that?
temple.
Jagu, அது எங்க locate ஆயிருக்கு?
I'm not sure. It's called the Somnath temple, which has the floating Jyotirlinga, but it was like
நீங்க கோனார் டெம்பிள் சொல்றீங்க, சன் டெம்பிள்.
two temples, both the temples, Somnath temple and Konark, sun temple of Konark. Yeah. Then some mysteries in nature. We had one session, no? The golden rock pagoda, why the stone is not falling. That Mount Arrogance.
the magnetic not
The waterfalls which goes up.
Yes, yes,
Jagu,
yes.
I have it now. I need to just tell a feedback. Jagu, can you go to the previous slide? I need to tell you one feedback.
Okay.
Jagu, you have put in Lilliput, spelling is long. You put that Lilliputta. It's Liput. Lilliput.
Where is it?
Lalaputta.
Laputa. You put
I don't know Laputa. Okay.
Laputa. I think Vignesh is autocorrect.
Yeah, Lilliput is correct spelling.
இல்லையா? Lilliput.
Might be autocorrect.
Yeah, it's like I don't know. I was typing and randomly it was going. So and then this is from our sessions. This mysteries thing. Then answer could be Earth's magnetic force. Then what is the history of magnetic levitation? Do you know who is like given this first idea of magnetic levitation? That's the father of modern rockets, Goddard. So the person who is considered the father of modern rocketry, his name is Goddard. The fuel, the liquid rockets. So he's the one first given this idea. Goddard.
Can you say?
Yeah, Robert H. Goddard.
Robert H. Goddard.
Second liner.
தெரியும்.
Then which is the spark moment? Like everything has, like Wright brothers had a spark moment, Abdul Kalam had a spark moment. This one scientist had a spark moment of designing a magnetic levitating train practically when he was standing on a traffic. When we are stuck in traffic, we'll think, no, is there something to fly and go to our place? Like that, he wanted to build something. So he started. The first patent is, I think it's here, 1969. This is the patent. And what is magnetic levitation technology, how it works? I'll show the video better. Where it all used, some areas of applications, and what are the patents? So there's so many patents, but it is much lesser than much lesser than other technologies. There are very less people doing research on magnetic levitation. That's what I was trying to explain. So I mentioned if you click on these links, it will take you to the patent page.
Please click it and show that, sir.
Yeah, then there's two types of magnet. Okay, I was explaining what is a natural magnet. How a magnet gets magnetic property? Who can tell? Don't know. Those who are attended last week, don't tell. Those who are not attended, what is how a natural magnet gets a magnetic property? Yes.
போன வாரம் நீங்க பண்ணீங்களா ஜக்கு? அந்த வீடியோ நீங்க அனுப்பிச்சக்கறன்னு சொன்னீங்க,
அனுப்பல. Today I will send it. So this has the answer.
attend பண்ணலன்னு நினைக்கிறேன்.
You did not attend. Only I think 7 to 8 people attended.
Yeah.
And I think most of you had exams. And this image has the answer. How a natural magnet gets this magnetic property? ஒரு நேச்சுரல் மேக்னெட் வந்து எப்படி என்னத்தை அட்ராக்ட் பண்ணுது?
ஈனா என்ன அர்த்தம், என்னன்னா என்ன அர்த்தம் ஜகா?
ஈனா எலக்ட்ரான், என்னன்னா நியூக்ளியஸ்.
எலக்ட்ரான் நியூட்ரான் ஆகுது.
அது ஆகுது, பட் how?
I know.
ஏனா
I told you answer in the image.
சுத்துற மாதிரி இருக்கு டயகிராம்ல.
So consider
ரெண்டுமே சேர்ந்துக்குமா?
No,
I say.
Yeah, tell Riya.
எலக்ட்ரானும் நியூட்ரானும் ஒரே டைரக்ஷன்ல சுத்தும்போது அது.
Yes. So if the electron and the nucleus both spin in same direction, the element gets the magnetic property. Okay. How to convert this?
Jagu, proton and neutron are involved in this.
Yes, obviously. Proton, neutron inside the nucleus, no?
எங்க சார் புரோட்டான் இருக்கு?
Hey, inside the nucleus there is.
நியூக்ளியர் நியூட்ரான் சொன்னீங்க.
சரி. Okay, in this thing there is a part where
magnetic field. So direction of the south poles and opposite poles attract.
மாறும்
how to
காம்பஸ்
identify
காணிக்கு மாறும்
Direction of the field.
தானே.
You can see that each compass is
So,
aligned in a different
you
direction.
take a magnetic compass, you take a natural magnet, go close to it, you can actually see it change.
ஆமா.
Okay. Then how to identify the magnetic lines? Okay, take a
அப்பனா இவன் தெரியாம தனமா வந்து காம்பஸ் வந்து மேக்னெட் பக்கத்துல வச்சுட்டு இனி அது இப்படி காமிட்டோம். ஆனா சரி இந்த போதுனா போன் வச்சு போயிட்டானா
அது ஒண்ணும் ஆகாது, don't worry. So take one, then one more experiment you can do. Take one natural magnet, put it inside sand, and கொஞ்ச நேரம் இது பண்ணினா you can collect lot of iron particles. Then take on A4 sheet, put
Pure sand.
sprinkle all this over the A4 sheet. Put one magnet below it. See, you can actually see the magnetic lines. Can you see?
புரியல ஜகு. ஒரு சாதாரண மண்ணையா ஜகு?
சாதாரண மண்ணுல வந்துட்டு
Go into tap it from below so that it to get the accurate line.
மேக்னெட் வச்சா என்ன வருது? பார்ட்டிகல்ஸா?
அடியில அதுல மேக்னெட்ல போட்டு பரட்டி எடுத்து அந்த மேக்னெட்ல மண்ணல போட்டு
மேக்னெட்டிக் ஃபீல்ட்.
yes, you can actually see the magnetic field. Visualize.
மேக்னெட்டிக் ரேஸ்.
ஆமா ஜகு.
Yeah, this is the image. Okay. Then
அது எப்படி ஆகுது? அது எப்படி
சரி, இப்போ வந்து electromagnet. What is an electromagnet? Oh, Himesh came. Okay. Himesh, are you here?
Yeah. Himesh, are you there?
இல்லையடா.
Jagu, Himesh left.
He's still in mute.
Yeah.
He is on this video.
Spaceman, Space I. Oh, who is Himesh here?
It's Himesh
Space
Sreevatsa
eye,
only.
space
Jagu.
eye.
Space I. Okay.
Yeah.
Himesh.
Himesh, you need to unmute.
Okay.
He's on.
You take a battery and you take this magnet. I'll finish this alone, da, and then we can take the Himesh. So go close to the battery and nothing will happen. Now you connect to one wire plus minus to the battery and now take this. Can you see the magnetic pole changing? You can try this with normal batteries.
Wow.
And why
Jagu,
you can tell
Jagu,
why
இது
it is happening?
நீங்க பண்ணீங்கன்னா
Because of the magnetic
ஜகு நீங்க
field.
சொன்னனே எனக்கு என்ன தோணுதுன்னா வந்து இதுக்கு முன்னாடி எக்ஸாம்பிள் காமிச்சீங்களா அந்த பர்முடா ட்ரையாங்கிள் மிஸ்ட்ரியில காம்பஸ் வந்து ஒழுங்கா காட்டாது என்ன
ஆமா
அப்போ
அதேதான்.
ஏன் வந்து இது மாதிரி மேக்னெட் ஃபீல்ட் எலக்ட்ரோ மேக்னெட்டிசம் ஏதோ இருக்கலாம்ல?
Correct. You are right. Okay, why it is happening? Who can tell? What is inside this wire?
காப்பர்
wire.
நான் ஃபர்ஸ்ட் சொன்னேன்.
How many of you tried?
Yeah, Jagu, it's copper.
Okay, wait.
Jagu,
How many of
எனக்கு
you?
இது first question நான் ட்ரையே பண்ணல
Sorry,
Jagu.
how many of you?
Jagu, இது நீங்க பண்ணீங்களா? Excuse me, Jagu.
Wait, how many of you took the nail and rolled copper wire in it, passed current through it and
Me, Jagu,
converted?
me. Me, Jagu.
So you don't need iron. You don't need iron. Just without iron, when you pass current through copper, it creates one magnetic field. That's what it's called electromagnetic.
Awesome, Jagu.
Okay, see, this is happening. Next, let's see how to take it next level.
Excuse me, Jagu.
Now, wait. Now take a nail.
காப்பர் நினைக்கிறேன் இது காப்பர் தானே அது.
Yeah, now nothing is happening. Now when you pass through current, the whole metal becomes a magnet. How this is happening? Electron movement is happening. You need to tell.
எலக்ட்ரோமேக்னடிசம் வந்து அதுல வந்துருச்சா சோ அதனால வருதா?
Adu okay. How this iron is becoming a magnet? That's my question. What is happening inside?
Copper wire. With the copper wire.
That's fine. Copper wire is fine. In current, everything is fine. But what is happening?
Charge it up.
அது வந்து
It is acquiring magnetic properties.
Yes.
The poles are activating.
So the electrons are aligned in such a way exactly like the natural magnet. So when the current passes through it, when there's a magnetic field, all the electrons inside the ion aligns in such a way which is exactly like the natural magnet. Okay, done. So I'll have one more detailed video that I will show you maybe when we get time. Okay, that I'll anyway send it in the group. I'll definitely send it in the group.
In YouTube?
Okay, our next presenter is here.
Himesh.
That's Himesh, the co-founder of Space Eye. Let me introduce Himesh. Himesh is co-founder of Space Eye and he's from PSBBMS.
MS OMR. He's also my school.
MS OMR and grade 7.
PSBB Millennium School OMR.
Okay, PSBB Millennium School OMR and his grade 7, and he's going to present on this topic, faster than the speed of light. And I know he did a research from the morning because he was asking so many doubts. And Himesh, the stage is all yours.
Yes, thank you, Jagu. So now, now no one would have expected that this is another theory. No one would have expected that, I'm sure. So this is the theory, my own idea. How can we go faster than the speed of light? Because getting slower than the speed of light, I compared it to a small microorganism traveling through the full moon. It's just, we can compare light speed in the whole universe. It's so slow in the cosmic terms. So if we want to explore it on a large scale, the speed of light is also very slow for us. If we take in that kind of concept, if I take it in my way, it is very slow. Now, what do we say?
And explain that in your way.
Now, can you see my screen?
Yes.
Yes.
So yeah, so that's what I just gave you the introduction. So yes, I have a solution. So mostly I was thinking, how can we do this? How can we like suddenly charge some particles and make something go faster than the speed of light? So going fast, making something charged. This I just searched on Google, supercharged charged electrons, charged particles. I found nothing. But I found one Wikipedia known as supercharge, and that was the smallest Wikipedia I've ever seen in my whole life. So that was so complicated that I didn't understand a single word in that. But we'll see that next time. Then after a few things, so this can be really helpful if we are able to tackle this. And other thing was if we can find a different state of matter while doing these things, it'll be really a big discovery in time of astrophysics and quantum physics. So yeah, so now before going on that research, that's going to be a raw form of research, which will mean that everyone will get to discuss on that research in this formal way. Everyone needs to raise their hands to do that, because this is going to be a formal research and it can be conducted by everyone, because that is like, how can we charge a particle? Like there's no clue in Google. Now this is fully our thing, our idea, everything of ours. So we'll go. So the Big Bang itself was faster than the speed of light. And so in that, this means that nothing can go faster than the speed of light. Nothing means not the real nothing, but nothing is just empty space or vacuum. So it can expand faster than the speed of light, because there's nothing to stop, nothing to expand. So it is a little tongue twister, but that's true. And then quantum entanglement, spooky action at a distance that spooked Albert Einstein. If you would have seen my the other presentation of quantum entanglement, you would know what is this. So here now, what does this do? That the information in this is kind of useless. So you cannot just transfer on information from here. So it's kind of useless, but it's kind of fascinating that what happens is that some kind of information travels. Suppose you say that two things are entangled. Now, if you now there are two socks. We don't know one is blue, one is black. Now, if we get to know one is blue, automatically we know another is black. So this is kind of normal sense thing, but now this is kind of an information in quantum terms, but it's kind of useless to us. So in this EPR experiment, it's something which you'll know later. I'll just say about that a few moments afterwards. So that proves this, and that's kind of but that's still incomplete. Quantum mechanics is always incomplete. We cannot determine anything. Then antimatter. We already had a huge session on antimatter propulsion and all that. TED talk. We looked on that, and I don't remember which set 8 or set 6, something like that. But we already saw this. So next, we need to know that about we can be doing this in two things: negative matter, antimatter, about the collision of two things, and doing that. Other ways, we can have the Alcubierre warp drive, which is the IXS Enterprise, and we have that helium laser, which cuts the space-time fabric and makes the full space-time fabric move. And similarly, that's one. And otherwise, we have these wormholes. So in wormholes, that is also, we had a whole session on that. So in that, these are like kind of imaginary and portals in universe, and it's like that. So there are some more things which I like to get yourself interested in, which is ER equals to EPR. So it is a conjecture. It means that it is a conclusion made without the full sufficient information. So the two entangled particles are connected by a wormhole, and it may be the basics for these seeing these getting this general relativity quantum mechanics into the theory of everything. So now the research is not over here. I would like to show everyone some research paper. So like I'll just speak here. That's not much of sharing my screen. So what is this supercharge I was talking about in the front, in the starting? It is something that transfers and transforms bosons into fermions and vice versa. So it is like it changes with spin half to spin 1 or spin 1 to spin half. So it is really if I send this thing to someone, no one will be able to understand a single word in this. But yeah, so this Wikipedia told a little confusing to me, and I saw many videos on Higgs bosons, which gives mass to everything, and now there it has a spin quantum number of 1, 2, 3, and fermions are same things, but they interact less and with matter and all that stuff. But at the same time, the spin quantum number is half, or always goes half. 1 by 2, 2 by 3 by 2, 5 by 2, goes like that. So the supercharge, I didn't I tried understanding this, but it is something that if I send this content to you in the chat box, I hope it will be more helpful for you. And these had some words which I never even used in my whole life. Like I asked my father, I asked my mother, but they itself didn't learn anything in their graduation. So I thought if this can be really interesting for all of you, and I don't know, it's not copy pasting. One second. Okay, how do I send it now? Okay,
Want to
so
share screen?
yes,
Yeah.
because this one of my control V option is not working.
Okay.
Right. But this should be a little like
Yeah, super star.
Wow.
so. This is a very small Wikipedia, because if you just see one word, which is fermions, you find this in its Wikipedia. Now, similarly, it is denoted by the symbol Q, and it transforms this into this. But this is not what I'm trying to find. Bosons and fermions, I'm trying to supercharge something or make it go lot of faster. But I was absolutely nothing, no clue I had.
Himesh, I need to tell you something. I cannot understand this Wikipedia. Wikipedia.
That's what he's saying.
That's what I'm saying.
Yeah, that means Himesh, are you copying from Google or you are seeing from YouTube? Because this Wikipedia is not even understandable.
There's not even single trace on Google, not even single trace on YouTube. Now you say, what can I do? This is such a kind of topic which I didn't even find a single thing.
That means why are you
searched
showing
for
the Wikipedia?
Why here to take the topic only?
Yeah, I thought
This is a topic which needs more research.
Yeah,
There is nothing in YouTube
Jagu,
or
but-
Google or
Yeah,
even
Jagu.
Wikipedia as only
Jagu,
thing.
அப்படின்னா ஏன்
Which
அந்த
means
புரியாத Wikipedia is presenting
if
Jagu?
you guys do research on this, there is easy way, shortcut to get Nobel Prize. I'm not joking, serious.
Yeah, but why do we need to research to get some prizes?
If you do this, you can actually find the secret to travel faster than the speed of light.
Yes, and that
but
famousness and the
I cannot
prize and all, it comes from its own.
Just click the fermions, no? I just saw this waves thing.
Yeah, he made
Something,
it
yeah, see,
explain it correctly.
how many of you remember this image?
எங்கேயோ பார்த்த மாதிரியே இருக்கு
Alcubris drive. How many of you remember Alcubris drive?
அந்த லைட்டோட ஃபாஸ்டா டிராவல் பண்ற ஸ்பேஸ் ஷிப் தானே
This image is exactly matching that.
This is stone space-time fabric which on which Alcubierre warp drive and access Enterprise can go on.
who's doing this?
No problem, let them do. I'll just
Can you just disable it?
yeah, I disabled. So there are some words which were unknown, like supersymmetry transfer.
I
now spinner. What is a spinner? Now this, what is this? They refer to the Z2 grading. What is Z2?
I don't know. Hey, they refers to Zeptova. Hey, someone in this place. All these various are
graded.
Mathematics.
This is, I don't know from where this comes from mathematics, but I just found this Z2. I found my thing here. Is the quotient ring of integers, but is totally.
I can understand.
Integers. If someone doesn't know integers, I'll just say that it is from minus infinity to plus infinity. It's known as integers. Now, what is this quotient ring, factor ring, difference ring?
I know you know the meaning, but like if we are explaining each and every single word, will take infinity.
Yeah,
can you say in your own words?
I tried to okay, Darsh, you are saying me to go on nasa.gov.
Just telling you can go to some website because now.
Yeah, instead of Wikipedia, because Wikipedia will be a not understandable thing.
And that's only NASA sometimes it will little.
I'll open simple Wikipedia. Wait.
What is simple Wikipedia about?
Simple Wikipedia.
It will be understanding
I think this will be very simple.
Yeah, simple.
Hey, this is Wikipedia. Like this Vignesh person and all be easy.
That's why I found
very good, right?
I found this when I was researching for quantum entanglement. Then
I got it already. When I started solo, I will use this Wikipedia a little bit. for concepts.
What is that supercharge? Supercharger. Oh my God.
Maybe like my OnePlus charger is called supercharger.
What supercharger, Jagu?
I don't know. It charges very fast.
OnePlus.
They call it supercharger.
I would like to show what I found on YouTube when I searched for supercharge.
Hey, please close that.
That's okay.
Hey, YouTube will be understandable.
Understandable, but not
Supercharge. Supercharge. See,
I'll say it personally.
1 minute, Himesh, but why are you doing this here? Guy, you can
This
do
is
it at
what
your
I got.
home, no?
This is
Sir,
what
but sir, but why is this live stream still going on?
Oh yeah.
Yeah, Himesh. Better you just presented that
That's
instead
because
of
like
researching that.
Vignesh, just cool down. Just cool down. Please don't panic. Everything is fine.
Let's search in NASA supercharge.
Yes. That's what I search in NASA.
Can you
right
end the
now.
live stream, Jagu?
Okay.
But I don't think so. It'll be in NASA also.
Okay, spaceman. Himesh, is the present? Once you tell me, is your presentation over? I'll end the live stream.
Our presentation is over. I want to discuss with everyone because this is such a kind of topic that no, I was out of ideas. I got one idea. I need to supercharge some party.
Okay. Then bye, YouTube viewers.
Bye.
Viewers. So
Bye from Arjun.
Bye, viewers.